Okay, all right. Well, good morning and happy Monday. It's week 4, moving right along. Today we're going to take a look at data wrangling with dplyr. Dplyr is one of the libraries in the tidyverse. So on Friday we looked at tidyr and pivoting data and tibbles and whatnot. Dplyr is also part of the tidyverse, and we're going to look at just kind of using it to, I guess, wrangle our data, getting some information out of it, and in my opinion, this is probably one of the most useful packages that exists ever in R. Okay, this package as well as ggplot, I think, are some of the most powerful packages available. Anyway, you load it up using library dplyr, or you can just do library tidyverse, and that will load up the entire tidyverse. Okay. This is taken from the dplyr vignette, which is part of their documentation. And again, like everything else in the tidyverse, everything is well documented, and so you can always go to tidyverse.org and look up each of these packages and look up the kind of the functions and the help files written about them. Okay, so when we work with our data, we got to kind of figure out what we want to do, and then we got to take what we want to do, put it into code that our computer can understand, and then we got to execute that thing. And dplyr, in what seems slightly counterintuitive, rather than just giving you like every single option in the world, it restricts you to just kind of a set of verbs, and you learn those verbs, and then you kind of string them together in a way to get the job done. Okay, but I think by kind of limiting the verbs that are available to you, you really learn them well, and when you learn them well, you can use them well. Okay. So I would say these are the primary verbs that exist in dplyr. There's more verbs in dplyr, but I would say these are the primary ones. Okay, we have select, filter, mutate, arrange, and summarize. Select selects columns, so we use select to select our variables. Filter filters rows, so select is for columns, filter is for rows. And we can often specify some kind of condition to decide which row or which cases we want to filter to. Mutate creates new columns, creates new variables. Arrange reorders the rows, and then summarize produces summary values. Summarize boils multiple values down to a single value. Okay, and then all of these things are paired with group by, which will perform the operations by groups, and I'll show you some examples of this. Here we have, there's a cheat sheet. The cheat sheet is quite handy. So I highly recommend to everybody download this cheat sheet, keep it somewhere that they can look at, maybe even print this out. This is one of the cheat sheets that I would recommend printing and having on hand. All right, for our data set, we're going to be working with this Star Wars data set. I don't know if we have any Star Wars fans in here. This data set is a little bit old now. It was created after the 7th Star Wars movie in the I guess the main sequence of Star Wars films. So there's currently 9 films in the Star Wars universe, along with a couple spin-off movies and TV shows. This is just on these kind of 7 Star Wars. So it's the original trilogy, the prequel trilogy, and then the sequel trilogy. And this came out after the first movie in the sequel trilogy, before the last 2. So anyway, this is what we have. So just looking at these first 7 Star Wars movies, it's got information on the different named characters. So there's lots of different kind of creatures and things that appear in the Star Wars universe, but not all of them are named. And so this has information about the name characters and some physical information, a little bit of other information. So we have, Luke Skywalker, a height of 172 centimeters, mass is 77 kilograms, hair color is blonde, skin color fair, eye color blue, birth year 19, sex male, gender masculine, home world Tatooine, species human. Also, 3 more variables that weren't included or are not visible here are the films that he's appeared in, the vehicles he's driven, starships he's commanded or piloted. Okay. Birth year is measured in, is recorded as years before the Battle of Yavin, which it's like getting into some, it's not that big of a deal. But okay, so the very first Star Wars movie, which is episode 4 in the timeline, the climax of the movie is they go to the Death Star and they blow it up. Sorry to spoil the ending there. And that's considered the Battle of Yavin. It's a great event of significant importance. So kind of like in our modern world, we have like the birth of Jesus or something as our 0 day. That Battle of Yavin is their 0 day. And so if you were born before that, your birth year was, so I guess Luke Skywalker was 19 years old during the Battle of Yavin, so his birth year was 19. C-3PO, I guess, was born on, I don't know, 112 years before that. And so you have that. And so anyway, that's this. Battle of Yavin. I don't know what happened. Actually, now I'm curious if you're born after the Battle of Yavin, what's your birth year? What's that? Should this be negative? Should these be like negative 19s? I don't know. Okay, but anyway. Interestingly enough, they use the metric system in the Star Wars universe, but anyway, that's you have that. Okay, C-3PO is a robot. Okay, so sex is none, but gender is masculine. And R2-D2, I guess masculine as well. I guess he's referred to as a he in the movies and stuff. So anyway, you're going to learn about Star Wars here just because this is the data set. We can select columns. Okay, select columns in using the select function. And so when you do select function, you specify the data frame or tibble. And so our tibble is called Star Wars. And then you type out the names of the columns that you want to select. So here we're going to say select name, homeworld, species, films. And so we select the name, Luke Skywalker from Tatooine, human species. Appeared in 5 films at that moment in time. All 3 in the original trilogy, 1 at the very end of the 3rd prequel film as a baby, and then also at the very end of the 7th movie. Okay, C-3PO had appeared in 6 movies and so on and so forth, also from Tatooine. And then you have that. I always talk about Tatooine being this nobody planet that no one cares about, but like all of the main important characters show up from there. I don't know. It'd be like, what would be the Tatooine of the US, where it's like you don't think it's important, but then so many important people come from there? I don't know. Well, anyway. All right. All right. So we have a pipe, okay? The pipe does this thing where you take the result from the previous line, okay, and you pipe it into the next function. Because normally without the pipe, if you had to do a whole bunch of stuff, you would often do, you have an object, you apply a function to it, you store that result somewhere. Then you take that result, you apply a function to it, and you store, result number 2. Then you take result number 2, and you apply a function, and you get result number 3. And then you take result number 3, apply a function, you get result number 4. Okay. With a pipe, you don't have to store all of those intermediate results. You just take original thing, pipe it into this function, take that result, pipe it into the next function, take that result, pipe it into the next function. Okay. I guess another alternative to pipes is you have original thing, put it inside a function, wrap that result inside another function, wrap that result inside another function, right? And so you have, when you read your code, you have to kind of start from the inside and work your way outward, which is, I guess, what you do in math. But you know, in computer code, it can be a little bit tough to do. So what a pipe does is it takes basically this. You have x pipe y, or a function of y, right? And that becomes function of x comma y. So the result, whatever's in front of the pipe, gets inserted as the first argument into the function that comes after the pipe. So the function select, normally its very first argument is the tibble that you're working on. Okay. So what we can do is we can say Star Wars, pipe that into select, and then from there, select these columns, name, homeworld, species, and films. So this line, select from Star Wars, name, homeworld, species, films, is exactly equivalent to Star Wars pipe, select, name, homeworld, species, films. Okay. Versions of R 4.1 and later also started including the native pipe. So the pipe kind of first appeared in the packages, and everybody agreed this is a very, very good development for R. And so the R core team decided to include a pipe in their base R as well. So you also have you'll also see the native pipe, which looks like this: vertical line greater than the sign versus the tidyr pipe. The tidyverse pipe is from package Magrider, which is percent greater than percent. Okay, so this is is there a difference between the native pipe and the Magrider pipe? There is some slight differences. You can read more about it. Probably for all of these examples, they're interchangeable. So it's up to you. You can insert a pipe using Control or Command-Shift-M to insert a pipe. Okay. All right, so let me give you your first view quiz answer. What is it? The letter B. B as in bear. B as in bear is your first view quiz answer. Okay, so here are some examples of selecting columns. So here you can use a negative sign and it will exclude those columns. So I could say select from Star Wars, pipe that into select, and select the columns other than name, eye color, and birth year, and we get the columns other than name, eye color, and birth year. Head, and we pipe that result into head 3. Head always just gives you kind of the first however many rows you select. So in this case, it's going to print out the first 3 rows from the results there. With select, you can also use colon notation. So we're accustomed to colon notation, say I'm doing like 4:9, and we'll get 4, 5, 6, 7, 8, 9. And here you can give it names of columns, and we're basically saying from name, the column name through eye color. So we get name, height, mass, hair color, skin color, eye color. And indeed, if I go back several slides, here's the original data frame or original tibble: name, height, mass, hair color, skin color, eye color. These are the columns through there, and then we also have birth year, sex, gender, homeworld, but I didn't select those. I just said give me name through eye color, and that's what we have. You have these helper functions for select, all right? And so sometimes you want to select columns. Sometimes you have big data sets with like 70 columns, 100 columns, and you want a way to handle all of these different columns without having to type out all of these different names. And so we have these select helpers. So you have functions like the column name contains a certain character string, or starts with a character string, or ends with a character string, matches a regular expression. You can do everything for select all the columns. Numeric range, if you have columns that are named something like x1, x2, x3, x4, it can select columns that way. And you can have like a vector, okay, that has column names. So somewhere else in your code, maybe you have a function or a loop that produces a vector of names, and you want to use that produced vector to end up selecting columns. And you can do that here. So just a quick example, I could do from Star Wars, select the column name and any column that ends with color. So we end up getting name, hair color, skin color, and eye color. Right? This here is a regular expression. So we're going to say select any column that matches this regular expression. And this regular expression $$ is equivalent to saying the column the name ends with an S. S followed by the end of the line, $ representing end of the line. And so we get mass, species, films, vehicles, starships. You can select with a variable. So again, here I created a vector called vars. And this vector is a character vector with the names of the columns I want to select. And so I can say select all of the variables vars that appear in that vector. And so I end up selecting name, mass, and height. Right? And so this is how we can use select. So select is for columns, selecting the columns. Filters for filtering rows, filters for rows. And so with filter, you give it a logical condition, something that's going to return true or false for every row, and it filters the rows accordingly. So here I could say name equals R2D2, and it's going to look at that name column, and we're going to get true or false for every entry in the table. And it's basically going to be false for everything where the name is not exactly equal to R2D2. And it will be true for the one row where it is R2D2 for the name. And so we end up selecting R2D2 with a height of 96, mass 32, hair color this, okay? And we have that. Here is, you can give filter multiple conditions. Using a comma is equivalent to using the ampersand for an and condition. So I could say filter, we want species in human or droid, right? Percent in percent. So it's very important that you do not use equals human or droid, okay? What would happen if I did... So what's the difference between Star Wars filter species percent in percent human droid versus equals human droid? What's the difference there? What?
The second one we match exactly, it will search exactly for human and droid, so the description is not human and droid.
It's not that it's going to search for human and droid. So what this will do, okay, let's just look at the results here, okay? So here I get 41, right? This is everybody who's, you can't see, let me just, okay. So human, droid, and stuff like that, okay? Let me just show you the original Star Wars data. Okay, so we got human, droid, human. Okay, human. What this is going to do, I got this vector here, and it's going to recycle the vector. So it goes human, droid. So this is going to return true if odd rows are human, and true if even rows are droid. But it's going to return false if you have human in an even row or droid in an odd row. So let me just show you the results here, okay? Okay, actually, it did it, but it gives me a warning message. All right, so let's see what happened, okay? So remember, this is the original Star Wars, so because remember, it's recycling human, droid, but here we have human, droid, human. So it ends up selecting Luke Skywalker and C-3PO, but it doesn't select R2-D2 or Darth Vader because R2D2 is in an odd row but says droid, and Darth Vader is in an even row but it says human. Okay, it selects Leia because she is human and in row 5, but it doesn't select Owen, but it does select Beru. Okay, so anyway, that is so you don't want to do this. You don't want to do equals equals. Do percent in percent. All right, so this is bad. Okay, but anyway, I have species in human or droid. Okay, height less than 175. So we only want to select people whose heights are less than 175, and we have that. Okay. You can also pair filter with regular expressions, and again, we haven't covered regular expressions, but we'll cover that I guess Wednesday and Friday. And there is a function called string detect. String detect returns a true or false depending on a character string. And so we can see, ask, do you detect capital F at the beginning and in the name, and we get a true or false, and we get the 2 characters in the Star Wars universe with that start with an F. And see, Finn, we get a NA for birth year. We don't know his. He was kidnapped by the Empire and forced into be was he a stormtrooper? What's I don't know, First Order something? What are they called? The bad guys? Are they still stormtroopers? I don't know. Okay, anyway. So yes, dplyr functions can be piped into each other. So here I have filter hair color equal to none, or eye color equal to black, and filter that. So remember, when we've been doing filter, we get all of the columns. There's 14 columns in the data frame. So we've been always getting 14 columns, but here I could say, after you filter it, just select these columns. Okay, so we're selecting people with none for hair color, so like Darth Vader, okay, or black eyes like Greedo, all right, and we're also just selecting the columns, name, species, homeworld, and so on and so forth. Okay. All right. Newt Gunray is not from Naboo, huh? Okay. All right. Well, anyway. You can also sort your columns or sort the results using a range. So here I've done select name, birth year, height, mass, and then after we've selected those columns, I say arrange birth year in descending order, and then if there's a tie for birth year, break the tie using mass in ascending order. So we get Yoda, born 896 years before Battle of Yavin, Jabba 600, Chewbacca 200. I think, I don't know. Are these exact years? I don't. Okay. Well, anyway, and then we have Ki Adi Mundi and Qui-Gon Jinn, both 92 years before Battle of Yavin, but the tie is broken based on mass. Okay. I think this Yoda is 896 is based on a throwaway line from Return of the Jedi, when right as he's about, anyway, he's like, when you're 900 years old. Whatever, in Yoda speak, he's like, you're not going to look as good as me, and then he dies, right? And I guess that movie takes place 4 years after. Well, anyway, so they just backdate that, and it says when he was 900, he was actually literally exactly 900 years, so he must have been born, anyway, 896. You can do slice. Slice will select rows just based on position. So you can just do slice rows 5 through 10, and it'll give you the 5th through 10th row there. Okay. There's another function. This is slice sample. This is, these are kind of just on the side, not as critical. And slice sample will just give you 5 randomly selected rows. This is handy if you just want to kind of get a quick little peek of what your data looks like. So a lot of times, I use head, right? And this is kind of a a common thing where you just say, hey, I just want to see the results of my data frame. I just want to look at the first few rows. So you just type in head, and it prints out usually like the first 6 rows of your data frame, which is fine and good, okay? But sometimes the top of your data frame doesn't necessarily look like the rest of your data frame, right? So like the top of your data frame might all be type A, then later on you got type B and type C, and perhaps your code and your functions work well for type A, but don't work well for type B or type C or something like that. And if you only type in head and you just see the results from type A, you might come to the incorrect conclusion that everything's working fine because it looks like it's working fine for type A, but it's actually not working well for type B or type C, and you wouldn't notice that if you're just using head. So if you do slice sample, not that this is going to be bulletproof, but it will select, random rows from throughout the data frame, and you're more likely to encounter also the type B and the type C. And if there are issues, you'll probably notice those and detect those, okay? Of course, you might have a situation where your code works for 99% of cases, but just 1 or 2% of cases, it doesn't work. And again, you're not going to notice that until you read through every single line of your output, okay? But slice sample can help you avoid, fairly glaring issues where it works for only just type A, but not types B, C, or D, or something like that. Slice min and slice max is kind of like arranging it and then selecting your top or your bottom few rows. So here I did slice max on mass, and that's kind of like selecting the 3 heaviest, okay? The 3 heaviest or 3 most massive things. That's one thing in the Star Wars universe, is that all the planets have the same level of gravity, right? So probably. Okay, but anyway, so we have Jabba with the most massive named character in the in Star Wars. Certainly, there are more massive creatures, but I don't think they have names, so they're not in their data set. Okay, we have mutate. Mutate is used to create new variables. New variables, probably based on existing variables. When you use mutate, it will create the new variable and throw it on at the end of your data set. So our original data set had 14 columns, and here I'm going to say mutate a new column called height underscore inches, or in, and I'm going to take our height in centimeters, divide by 2.54, so we get a height in inches. And you can see that new variable appears at the very end, after vehicles and starships and so on and so forth. So we have height in inches, and it says that's a double. If you want to view that, you probably have to pair that with a select. So I'm going to say mutate height in inches, and then select name height in inches. And so now I get Luke Skywalker, height 172 centimeters, 67.7 inches. One thing about the mutate is it's creating a new column. So whatever you're mutating, whatever this new variable you're creating, has to have the same number of entries as you have rows in the table. So if you have 87 rows in the table, this new column has to have 87 values, right? Otherwise, it's not going to work. So it's a little bit silly, but I've used this function cumulative mean. Cumulative mean makes more sense for some like time series data, where you have your first and your second and your third and so on and so forth. But cumulative mean is kind of like a running mean. So our first value was 77, so our cumulative mean is 77. Our second value is 75, so the cumulative mean of 77 and 75 is 76. Our third value is 32. So 77, 75, and 32 averaged together is 61.3, so on and so forth, and this is just the cumulative mean. And so as we keep adding values up through the 87th value, so at the 86th value, our cumulative mean is the mean of those first 86 values. At the 87th, the cumulative mean is the mean of those 87 values. What would happen if I didn't use cumulative mean, but I just used mean? And I used mutate. What would end up happening? Well, so mean, if you give it 87 values and you say, what's the mean of 87 values? You get one value, right? So how is mutate going to handle that? So mutate would just end up copying that. So here I've got Star Wars. I'm going to do mutate mean mass, and it's going to be the mean of mass. If I have to include na.rm equals true because there's NAs. If you don't include that, you're going to just get NAs everywhere. And I'm going to just select name, mass, and mean mass. And what you're going to see is that this mean of all the mass values, 97.3, just gets duplicated everywhere. Okay, this is probably not what you had in mind, right? Or maybe it is, but this is what will, if you use mutate with just a plain summary function, a summary function that just returns one value, this is what you're going to get. Okay. So keep that in mind. And again, if you don't, I think you've all encountered the NA issue. If you don't include na.rm equals true, and if you have a single NA, you're just going to get NAs, right? So it's kind of like, someone has 3 children. One child is 10 years old, another child is 15 years old. We don't know the age of the third child. What's the average age of this person's kids? And the answer is, I don't know, right? You can't give us an average if you only know 2 out of the 3. You can say, what's the average of the ones I've told you? 10 and 15, sure, the average is 12.5. But the average of all 3 is going to be unknown here. I feel like a lot of times students keep coming in at like 9:30. I don't know what it's fine. It's just kind of funny to me. But anyway, so these are all functions that are handy to use with, say, mutate, because this will take a vector of values and will produce a vector of values. So you have things like the cumulative mean and the cumulative sum and the cumulative min and cumulative max. You also have these other functions, pmin, between, lead, lag, stuff like that. These are just some examples here. Again, it doesn't quite make sense to use these functions on these variables. Most of these functions make sense for, say, time series values. But here, but they work on any set of numeric values. So I'm just going to run them. And let me just show you what happens. So here, cumulative min is kind of like a world record minimum value we've seen. So like if you think about race times, the world record's always the lowest that has happened so far, and only until somebody beats that record, it remains the same, right? So it's like, what's the minimum value we've seen so far? We start off at 77, then the next value we see is 75, so that's our new world record. Then we see 32, that's our new world record, and we don't see anything that beats 32, so it just remains 32, okay? Ratio. Here I did mass divided by the mean of the mass. Okay, so again, the mean, so this mean mass NARM true is 97.3. So we're going to just take mass divided by the mean of mass, and we do 77 divided by 97.3, and we get 0.791. 75 divided by 97.3 is 0.771, so on and so forth. So here we're calculating the mass divided by, and it's using that same value, 97.3 for everyone. Okay, mass year p-min. P-min is element-wise minimum. Okay, so here, so normally when we think of min, we take a column and we say, what's the smallest value in this column? Okay, what p-min does is, for each row, if you have multiple values in that row, you specify like which columns you want to look at, and you say, between these columns, what's the smallest value? So we're going to say between the mass and the birth year, what is the smaller value? 77 and 19, the minimum value there is 19. Between 75 and 112, what's the minimum value? 75. Between 32 and 33, what's the minimum value? 32. So it's kind of like a row-wise minimum. Okay, row-wise minimum is what p-min is. Lag just takes one column. So here I'm just taking the mass year p-min column, and I'm saying lag it 2 steps. So again, lag makes most sense for time series data. So if you have like monthly data and you want to compare January of 2024 with January of 2023, you might lag it 12 months. And then you can compare this, this year's April with last year's April, okay, or something like that. So you can lag something 12 months or something like that. And it just offsets. It takes all the values in this column and just offsets it by 2. Lead does the exact same thing, but offsets in the opposite direction. Okay, so those are just some examples of mutate. Okay, let me give you your second view quiz answer. The letter E. E as in elephant. E. Summarize is used with summary functions. So a summary function, just to remind you, takes multiple values and boils it down to a single number. So any kind of summary function like the mean and the median, those are summary functions. You give it 100 numbers and you say find the mean of these 100 numbers, you get 1 number. What's the median of these 40 values? You get 1 number. What's the standard deviation? What's the variance? What's the min? What's the max? What's the 25th percentile? What's the 87th percentile? Those are all summary functions because they give you exactly 1 value, even if you give it 10 values, 100 values, or 1,000 values. They boil it down to 1. So those are summary functions. And normally, when we ask one something like the mean, we just say, hey, select the column, calculate the mean. And when you first use summarize, it feels like, man, this is a lot of work, and I'm getting it into a format that feels a little bit strange. But this is actually quite useful, right? So here I'm going to say, from Star Wars, select these 2 columns, height and mass, and then calculate these summary things. And you have to give it the name of the column. So summarize is always going to produce a table with columns, and each column corresponds to a summary function that you've provided, or a formula, a command that you've provided. So I'm going to say create a column called average height, and the entry in that column is going to be found by doing mean height, ignore the missing values. Create an entry called var underscore height, and the entries will be found by doing variance of the height, ignore missing values. Create an entry called average underscore mass, and that's going to be mean of mass, ignore the missing values. Okay, the last one is create a column called count, and it's just going to be found by doing n, which is the count of how many, n parentheses, which is the count of how many rows are being summarized here. And so we get, this is our entry, 174 for the average height, 209 and stuff. There's more decimal places, but again, the default settings in dplyr and the tidyverse is to kind of just not produce a whole bunch of significant figures. And you can always ask for more significant figures, but this is what we have here. Okay, so that's that. Summarize is really most powerful when you pair it with the group by function. Oh, so by the way, when I use summarize, I spell it with an S because dplyr has been around for a little while, and Hadley Wickham from New Zealand spells it with an S. Later on, they added summarize with a Z, but I'm just accustomed to using summarize with an S. It's not wrong to use summarize with a Z, but I'm just accustomed to spelling it that way now. Okay, group by takes a categorical variable, creates groups based on that. So here I can say group by species, and dplyr creates groups. Now, when you just run group by without summarize, it doesn't look like anything's happened. So if I say, hey, group by species, and then select name, height, mass, and species, we still have 87 entries in here. We just have this one line that says groups. There's 38 groups based on species. That's all we see. However, you pair group by with summarize, and this is where some, I guess, magic starts to happen here. Okay, I said group by species, select these columns, and then summarize. Remember, summarize, what does it do? It's going to create columns. The column names will be mean height, where I'm going to do mean height, standard deviation height, where I calculate standard deviation height, mean mass, standard deviation mass, and count. And I do that, and now I get species Alina, mean height 79, standard deviation of height NA. I guess there was only one Alina species. I don't even know, what is that? Now I'm curious. Okay, who is this? Species of short sentient reptiles from the planet of Aline. Okay, well, all right, great. Well, anyway, that's what we have. Alina, mean height 79, mean mass. I guess there's just one person. We have 1 here, okay? But we get now, how many rows do I have? I have 38. I have 38 rows, 1 for each of these groups. We had back here in the groups, we had 38 different unique species, so we get 1 entry for each species. Now, when you have only 1 entry, you can't calculate a standard deviation when you have only 1 value, okay? But here we have 6 droids, and we can calculate the standard deviation for the height and the mass for that. Notice I had selected name, height, mass, and species, but when I said summarize, what happened to name? It just goes away, okay? Because think about it, right? Here we have a classroom, and I don't know how many of you are here, 20 something, okay? But we can measure record information about each of you, right? I could say, hey, write down your name, give me your height and your age, or something like that. And I say, okay, let's average everybody's height. Okay, we can do that. Okay, let's average everyone's age. We can do that. Okay, average the name. We can't do that, right? There's no way to summarize name here, right? You can't. Name is to identify individuals, and by kind of definition, when we summarize, we no longer care about individuals. We're just getting a one number for the entire group. Okay, so yeah, things like name just disappear. Now, if I say, give me the first most alphabetical name, we could do that, right? And it'll be something like Adam, or I don't know what, some name that starts with an A, okay, probably, or B, something early in the alphabet. Okay, are we okay with starting to see these pipes? So we're saying Star Wars, then group by, then select, then summarize. Okay, we can continue piping. We can take this result, 38 rows, 6 columns, and I can pipe that into another thing where I say, you know what? I don't care about these ones where there's only 1 person in that entire species. So I'm going to pipe that into filter, where count I want to be greater than 1. So now we just get these 6 rows. Okay, Tibble 6 by 6. 6 rows, 6 columns. I'm going to arrange them in descending order by count. And the Star Wars universe, despite taking place across the galaxy or whatever, still very human-centric, okay? We have 35 named human characters, 6 droid droid characters, 4 unknown species, 3 Gungans, 2 Kaminoans, and so on and so forth. Okay, so this is what we have, and this is our information here. Yeah, question?
Yeah, for the last page, I think it was sorted in alphabetical order of species.
Yeah, it's.
I wonder if that is from the group by.
Yes. So when you do group by species, it's going to sort on that whatever you grouped by, and it's going to kind of use the default sorting, which is if it's character, it'll alphabetically sort, and if it's like you're grouping by a numeric variable, it'll be in ascending order. Okay, a discrete numeric variable. So you can't group by a continuous numeric variable. Okay. You can pair group bys with things like mutate. So what this will do is it will calculate the summary values by group. So here I'm going to say, okay, filter just to humans and droids. Okay, we're going to select name, species, and height. We're going to group by the species. Okay, and I'm not using a summarize here. I'm just saying mutate. But what am I mutating? I want to calculate a z-score. Z-score is found by taking the value minus the mean divided by the standard deviation. However, how am I calculating the mean? Because I have the group by, I'm going to calculate the means by group. So I have humans and droids, so I'm going to calculate the mean for humans, and I'm going to calculate the mean for droids. So what we'll notice here is that Luke Skywalker's z-score is negative, meaning he is below average for humans, okay? Whereas C-3PO has a positive z-score because he is above average height for droids, despite Luke Skywalker's height being 172 and C-3PO's height being 167. So C-3PO is shorter than Luke Skywalker, but he has a positive z-score because he is above average compared to the other droids, okay? Luke Skywalker is taller than C-3PO, but he is below average compared to the other humans, right? So that's what we have here, okay? And that's because we've grouped by species. We've grouped by species, and so when we calculate mean and standard deviation, we're calculating the mean height for humans, and we're calculating the mean height for droids, and standard deviation likewise as well, okay? If I get rid of this group by line, okay? Oh, so just one kind of style thing is generally you want to put a pipe, one pipe per line, and you put the pipe at the end of the line, okay? One pipe per line, generally. And so so that way you can kind of comment out steps if you want, all right? So here it's the exact same code. All I've done is I've put a little hash mark in front of group by, and it just comments out that group by step. And so here, because I'm no longer grouping by species, now we're calculating the mean and standard deviation for everybody in this data. So Luke Skywalker with a height of 172 has a z-score that is slightly positive, 0.03, just slightly above the average. And C-3PO with a height of 167 is slightly below average with a z-score of negative 0.168. Right? So group by paired with a mutate now would calculate these kind of values. Anytime you have a summary function, it's being done by group. Here you can apply groups, multiple groups. You can group by more than one variable, and this is just some toy data. Here I've got Afghanistan, Brazil, China. This is just A, B, and C, not actually significant. These are just made-up numbers, 1, 2, and 3, okay? And then we've got years, 1999, 2000, 99, 2000, 99, 2000, sex, female, male, so on and so forth, okay? This is just some made-up toy data. It doesn't actually signify anything here. But here I can group by multiple variables. I'm going to group by country and year. So if I group by country and year, how many groups am I going to have? I'm going to end up having 6 groups. I'm going to have Afghanistan 99, Afghanistan 2000, Brazil 99, Brazil 2000, China 99, China 2000, right? 6 combinations of country and year. And so I'm going to just do summarize some cases, and those numbers get added together, and so here we have, okay? Now it says, so I've grouped by country and year. This is the summary table. It still carries additional group information on country here, right? It says country, groups country 3, and so if I take these results, summary 1, and I run them through summarize again, now I get Afghanistan, Brazil, China. Afghanistan has a total of 4 cases, Brazil 8, China 12. And if I run summarize again, I get a total of 24 because no more groups, okay? Here I do the group by, but this time I do group by year, then country, and what happens, okay? The table is now arranged first by year, then by country. So I get 99 Afghanistan, 99 Brazil, 99 China, 2000 Afghanistan, 2000 B, 2000 C, okay? And then if I run group by, if I run summarize here again, how many rows am I going to get in the next table if I summarize here? I'm going to get 2 because I have 2 groups based on year. We've got group by year, then country, and so year is now the top level group. So when I summarize here, I'm going to get 99 has a total of 12, 2000 has a total of 12. And if I do summarize there again, now I just get 24, okay? All right, we are out of time. I've got a couple stuff on 2-table verbs, on joins and whatnot. This is very similar to SQL if you've seen that before. Let me give you your last view quiz answer. The letter A as in apple, is our final view quiz answer. And I'll just leave it up to you to kind of go through these notes on the 2-table verbs on your own time. which will cover kind of these joins. All right, have a great rest of your day, and we'll see you on Wednesday.